So continuing our lessons with proving congruent or triangles congruent, we're going to take a look at two other methods today. One is going to be the ASA, angle side angle case, and one is SSS, side side side. And then we're going to look at this other abbreviation, explaining how once our triangles are congruent, all of the parts will be congruent. So first looking at ASA, angle side angle. So notice the picture on the right that is showing you the side this time is now going to be in between the two angles. So we're going to call that side the included side, meaning it's going to be the side that would touch both angles. So keeping that in mind, we have this diagram to the right, and it says in the diagram we have side AE congruent to side BE, and we have angle 1 congruent to angle 2. So do we have enough information to prove the triangles are congruent? Well, we do, even though we only have two parts. The third part's going to come from that angle 3 being congruent to angle 4. Those are vertical angles, and we know that vertical angles are congruent. So by using that piece of information, and now looking at my triangles, I could say yes, the triangles will be congruent. So triangle AEC will be congruent to triangle BED, and our method would be by angle side angle. So then it wants to know, well, why would CE have to be congruent to DE? Well, if our triangles are congruent, we've always been able to say there's some rigid motion that would take one onto the other. So if I took this segment that connects AB and I made the perpendicular bisector, that provides to us this line. It's going to be a good line of reflection. I could reflect this triangle over the line of reflection, and I could see that they would map onto each other. Meaning if my triangles are congruent, well, now I could see all of the corresponding parts, the parts that match up, have to be congruent. And side CE and DE are going to be considered your corresponding parts. So what that does is that says, okay, well, if triangles are congruent, then all corresponding parts, meaning parts that match up after rigid motion, all corresponding parts are also congruent. And the nice thing that we get is a nice abbreviation, so we don't always have to explain that every single time. We get this abbreviation that says CPCTC, standing for corresponding parts of congruent triangles are congruent. Big key thing here is it's of congruent triangles. I need to know that my triangles are congruent first before I can state that the parts are congruent. So using that idea, we need to know about corresponding parts. So it's the parts, we keep saying that parts that match up. So we're going to look at this image to the right, and we know right now triangle EAC is congruent to FDB. So because they are congruent, we have parts that are corresponding and parts that will match up. So first, the corresponding sides. Real easy thing is if I look at this mapping and I take, to make a side, two letters, let's say for instance the first two letters, EA, that will automatically correspond to the first two letters of the other triangle, FD. So on my picture I can see EA and FD, those are corresponding parts. Take the next two letters, so perhaps AC. Well, that's going to be corresponding to the next two letters in the other triangle, DB. So here's AC on the bottom, and then here is DB on the bottom. And then our last two, take your first letter and your last letter, so there's EC. That should be congruent to FB. And again, if I look, well, here's EC on this side, here's FB on that side. Okay, so not only can we do it with sides, but we could do it with angles. Well, with angles, all we need is one letter. So if I take the first letter, angle E, I can see that will correspond with the first letter in the other triangle, F. And if we take the middle letter, well, that's angle A, I can see that that would correspond to the middle letter in the other triangle, angle D. So that's those two. Now the third ones we're going to have to be careful with. I'm going to need to have 3 letters to name these angles. And I would just say, okay, I know it's situated, let's say it's C. So if I need 3 letters, if I were to trace it out, that C has to be in the middle. Okay, so for instance, I could name that angle ACE. And if I follow that on the picture, I'm going from A to C to E. So I went middle letter, third letter, first letter. I could do the same thing then on the other triangle. So middle letter, third letter, first letter. So just by knowing that those triangles are congruent, that will give me all of the parts that are congruent, and all I need is that corresponding statement. Okay. Next method we're going to look at is SSS, side, side, side. Should be pretty easy to recognize because it's only dealing with the sides of the triangles. There are no angles being used. So we are told AE is congruent to BE. We are told AC is congruent to BD. And we're told CE is congruent to DE. So do we have enough information to prove the triangle is congruent? Yes, we do. We have all 3 sides, so we can say the triangles are congruent because of side, side, side. Now, what else would we know? Well, since our triangles are congruent, that means all of the parts are congruent, all of the corresponding parts. So I could use the numbers, perhaps, like I could say angle 1 is congruent to angle 2, that would work. I could use the letters. So for instance, if I'm going to name angle C, well, that's the last letter, that's got to be corresponding to angle D. And we could also name that angle at E. We could either use the numbers, so I could say 3 is congruent to 4. Or if I were to name E and match up the corresponding parts, so keep in mind, E we said would have to be that middle letter when we name it. So maybe I'm going to go AEC. So I can say AEC, first, second, third letter. Okay, so I have to do the same on the other side, which means it would be angle BED. It's just keeping the parts in order and matching them up. And this is all coming from the fact we had that CPCTC, standing for corresponding parts of congruent triangles are congruent. So my triangles are congruent, parts are congruent. Okay, so we're going to take a look at a proof. So always start the proof off with the given. Always go and label your picture if we have any congruent statements. And this time they're telling us we have a circle with centers A and B. Okay, and they intersect at C and D. So we don't really have any congruent statements to begin with, which means we have to search for 3 total congruent statements. But knowing these are circles, I'm going to take a look at the circle and take a look at first segment AC and segment AD. And I notice that those are both radii of that circle A. And I know all radii are congruent. So I have AC is congruent to AD. If we go to the other circle, circle B, I can say the same thing. BC is a radii of circle B, and BD is a radii of circle B. So I can say in the same line at the same time, because I'm using the same reason, BC and BD are equal. And our reason is just that all radii, plural of radius, are congruent. So that gives us 2 congruent statements. If we're thinking checklist here, here's 1, here's 2, I need a third. So looking at the picture, looking at our triangles, I can see that they share a side. They have a common side here, side AB. So we have that reflexive property that would allow us to say AB is congruent to itself. So here's our reflexive property. That's our third congruent statement. So that means, okay, now I'm going to go and check and see, does it fit? And it does. This fits into our side, side, side method of proving triangles congruent. So triangle ACB congruent to triangle ADB. And there's our proof. Now on the next page, we want to think to ourselves, okay, so if we are ever asked to prove angles congruent or sides congruent, it doesn't necessarily mean we need a different train of thought. That probably still means try and get your triangles congruent first. Then once you know your triangles are congruent, then we can use CPCTC. Okay, so let's take a look. Again, always start with your given. So we have BD being congruent to CD, and E is the midpoint of BC. So this time we actually have two givens. Only one of them is a congruence statement, so that means we need to find two more. But I am going to go over to my picture and I'm going to mark it so I know that BD is congruent to CD. And I'm also noticing I'm not proving triangles congruent, rather I'm proving angles. Well, that's okay. Same train of thought. Let's get our triangles congruent first, and then we can prove our parts congruent. So I still am looking for three congruent statements. Knowing that E is the midpoint, I know midpoints split a segment into two equal parts, so that means I should have two equal parts, BE and CE. So mark it on my picture, and I'm going to just say over here, midpoints split a segment into two equal parts. And our third, well, we've used up our given. I'm going to go to my picture, and again, I'm going to notice they're sharing a side. They're sharing that side DE. So I can say DE is congruent to DE because it is reflexive. And I'm counting. There's 1, 2, 3. That means look at your picture and see, does it fall into one of the methods to prove triangles congruent? And it does. So I can now say triangle BDE is congruent to triangle CDE, keeping our parts in order, corresponding parts. And I can say because of side, side, side. Now we're not done. Just because we prove triangles congruent, we're not done. Notice what you are proving. You are proving angles. Well, we had said before, if my triangles are congruent, I know my angles are congruent. So the very next step, we can actually say, okay, well, DEB, which is this angle here, is congruent to angle DEC, which is this angle here, and our reason, we have CPCTC. Again, corresponding parts of congruent triangles are congruent, meaning my triangles are congruent, so I know my parts are congruent. Hope this helped. We will go through a little bit more of this in class and keep practicing.